Welcome to Lube Maintain, your trusted platform for practical lubrication and asset reliability knowledge. If you've ever struggled to choose the right oil viscosity because of confusing numbers like SAE, AGMA, or centistokes, you're not alone. Today, we break it all down by explaining ISO Viscosity Grades, or ISO VG, the global language of industrial lubrication. Viscosity is simply a fluid's resistance to flow. Water flows easily. That's low viscosity. Honey flows slowly. That's high viscosity. In machinery, viscosity describes how strongly oil resists being pushed or sheared between moving surfaces. Imagine a water skier. On water, the ski cuts easily and throws up a lot of spray. On thick gear oil like ISO VG 220, the spray would be much smaller, because the oil resists motion far more. This resistance is exactly what machines rely on to maintain protective oil films. From a maintenance and design perspective, viscosity is viewed in two ways. Absolute or dynamic viscosity measures resistance to flow under pressure. It's measured in centipoise and is important in pressurized systems like hydraulics. Kinematic viscosity measures resistance to flow under gravity. It's measured in centistokes, or C-saint. For industrial lubrication, kinematic viscosity is the most widely used, and it forms the basis of the ISO VG system. Viscosity is measured using a viscometer, where oil flows through a calibrated tube at a controlled temperature. Thin oils flow quickly. Thick oils flow slowly. Temperature plays a critical role. Lower temperatures make oil thicker. Higher temperatures make oil thinner. That's why viscosity values are always linked to a specific temperature. Historically, viscosity was expressed using many systems, SAE, AGMA, SUS, centistokes, and at different temperatures. This created confusion between lubricant suppliers, equipment manufacturers, and maintenance teams. To solve this, ISO, together with leading technical organizations, introduced ISO viscosity grades in 1975. The objective was simple: create one universal viscosity standard that everyone could understand and apply. ISO viscosity grades are based on kinematic viscosity measured at 40 degrees Celsius, representative of most industrial operating conditions. Each ISO VG number represents the midpoint viscosity in centistokes, with an allowable tolerance of plus or minus 10%. For example, ISO VG 68 has a midpoint of 68 centistokes, with limits from 61 to 75. ISO VG 220 has a midpoint of 220 centistokes, with limits from 198 to 242. Each grade increases by roughly 50% from the previous one, creating a logical, scalable progression. This allows maintenance professionals to select lubricants confidently and consistently. It's important to understand what ISO VG represents. It defines viscosity only. It does not define oil quality, additives, or performance level. Two oils can both be ISO VG 68, yet behave very differently depending on base oil quality, additive chemistry, and application severity. ISO VG ensures that everyone speaks the same viscosity language, from the designer to the maintainer. At Lube Maintain, we believe that better lubrication knowledge leads to better reliability outcomes. Understanding ISO viscosity grades helps you protect critical assets, reduce wear and energy losses, and improve maintenance decision-making. If this video added value, like, subscribe, and share it with your maintenance team. Let us know in the comments what lubrication topic you'd like us to cover next.